Good morning. Let's talk about this new bell ringer. If ants covered 0.7 inches squared, how many ants are needed to cover a basketball if the surface area is 277 inches squared? Now, I want you to think about this. If you think back to the assignment from yesterday about how many people fit into a 5x5 square, and we use that information to determine how many people in a parade route, we can kind of do the same thing here. Now, this ant only covers 0.7 inches squared. That's just a small portion. But if the cover of a basketball, to cover a basketball, if the basketball surface area is 277 inches squared, how do we determine how many ants cover it? We have a ratio of 1 ant per 0.7 inches squared. Well, how many 0.7 inches squared are in 277 inches squared? Well, that's pretty simple. You just divide 277 by 0.7. So 277 divided by 0.7. And yeah, you thought I was going to give you the answer, didn't I? No, you need to do that on the calculator yourself. So take a look at it. Let's go to good things. Let's share some joy. All right. So got to take care of a few things. Working on my commercial driver's license. Take test on Tuesday. You should be watching this video on that day. I probably won't be in class. Matter of fact, I'm certain I won't be. I will be at this time probably taking my test. Pass some good thoughts. Maybe I'll pass it and I'll be able to drive a bus once I get back. Anyway, that's my good thing. Please do me a solid favor and pass along some of these good things that you get to share. Like, for instance, last Friday we beat Navasota. Football team's 2-1. First time that I can remember where we were ever 2-1. So, since I've been to Rudder anyway. So let's go, right? Let's go. Why estimation? Okay, well, what are some other things estimation can be useful or helpful to people or society in general? Well, let's think about that. Kind of alluded to it in yesterday's assignment. We talked about the fire marshal. How does he determine whether or not a venue or a restaurant or some gathering place remains safe by the number of people? Well, you got a lot of seats and tables and everything hanging around. You only got a certain size door area. We need to understand how long would it take a certain number of people to leave that venue and still not hurt each other in the process. So we estimate exactly how many people would fit at full capacity, and then we reduce the number until we get to a place where we feel the risk involved in people escaping from an emergency situation is diminished to the point where we can live with it. Fire marshal makes those rules, and they have a certain ratio of people per venue, depending on the size and type of venue it is and what's inside that venue. All right, let's talk about this. How many tennis balls can fit inside the classroom? This classroom that we're in, 60 seconds. Personally, make your own estimate of how many tennis balls are needed to fill the classroom. I'm going to leave a few tennis balls out. I want you to think about that for a second. How many tennis balls? Go. That's 5 seconds. I'm not going to time you. Pause the thing. Give yourself 60 seconds and determine how many tennis balls you believe might fill this classroom. All right. Now that you've done it by yourself, get a partner. Somebody. Choose someone in this classroom. Now this time, take 5 minutes and estimate the number of tennis balls required to fill this room. Now, I'll be honest with you. It's going to help a lot if you create a sketch of the room. So let's do that now. Time starts now. Okay, I'm not going to make you wait 5 minutes on this video. I'm going to move on, but I do expect you to pause and take 5 minutes to actually do this. Participation helps immensely. If you don't participate in the activity, it's not helping you at all. So I expect you to actually participate. Now, let's think about these two estimates. Do you think your estimate's too small? I don't know. You maybe were a little conservative. You thought maybe it might not fill, or you might have too many, and you're afraid that or you might not have enough to fill the whole room. Well, maybe it's too large. Maybe you just went a little overboard and, I think it's going to be this many, and you're not sure that you think you might have went way overboard. So why do you think either? Why do you think it's too small or too large? Well, this is estimation. There's no clear method to do it. But what method did you use? Did you just guess? Well, the first time you were told to guess. The second time you were told to come up with some kind of strategy to determine it with a partner. Now, here's some material. I'm going to give you a few tennis balls, and I'm going to give you a box. And I want you to find some way to get those tennis balls in that box, and then find out how that box can help you determine how many tennis balls will fill this room. Now, keep everything in mind. Try to remember every detail so that you get a good, accurate number. Now, remember, this is going to be a large number, so estimation is going to be a percentage off, could be a couple hundred. So keep that in mind when you make your estimation, all right? I'm going to give you about 5 more minutes, and please stop the video and think about it. Draw sketches if you need to. All right, let's think about these tennis balls. You should have already completed all 3 of those exercises. Guess the number of tennis balls in the classroom. A little strategy thinking with a partner in your classroom about how many tennis balls will fill it. And then one more time with some items that might help you determine. A few tennis balls in a box. You can find a ratio of the tennis balls to box and find the volume of that box. And you can say, for that volume of box, this many tennis balls fit. Find out how many volumes of that box fit into the volume of this classroom. And that could give you an estimation of how many tennis balls, if you think of that ratio-wise. So what mathematical model of a tennis ball did your group use? I kind of gave you an example right there, didn't I? Looks like I hit it twice. What simplifications or assumptions did you make? All right. Did you assume that we have no desks in the classroom? Chairs, cabinets, cavities where the windows are, cavities where the doors are, cows where the computers are. Do we have anything that might cause a little fewer tennis balls or a little more? Are the drawers to my cabinets open? Do the tennis balls fill up the spots inside my bookcases? What kind of assumptions did you make, or simplifications? The more you talk about the different things in a classroom, the more difficult the problem becomes. So a simplification or assumption that says there's nothing in the room when we make this assumption, or when we make this estimation, that assumption's good for the soul because it makes it less complicated. All right, who thought about estimation, and why is this guy so important? So this fella right here, as you can see, he's got all kinds of mathematical equations on his chalkboard. And yes, that's a chalkboard, not a whiteboard. Back then, they didn't have whiteboards, they had chalkboards. Well, this guy is Enrico Fermi. He's an Italian physicist known for his ability to take limited information and arrive at a reasonable numerical estimate. So Fermi questions. How large is the crowd? How many tennis balls fit in a classroom? Those are examples of Fermi questions. Requires estimating physical quantities to produce an answer. Enrico Fermi set a lower estimate, one that the value had to be more than, and a higher estimate, one that the value he knew was less than. He then worked those problems using this approach and reached numerical estimates within identified limits. So he would give a lower and upper limit to his estimate. So while working at the University of Chicago, he was faced with the question, how many piano tuners were then in the city of Chicago? Now, in today's society, the number of piano tuners probably not really relevant to any question we might have, because most people use electric keyboards now to play the piano. But there is a need for piano tuners, but not nearly as many as there were back when he was around. The time he was posed with this question, every 5th house had a piano, and that's true in the city of Chicago.